Okay, we are into the second question now. This is a trickier question. Let me have some space here for this question. And then we start this. Okay. The question says, find how many ways 4 men and 2 women can stand in a line if the 2 women must be at the front. Okay, so we have the number of men we have, that is, there are 4 men, and the number of women, that is going to be 2. Okay. Now suppose there was no condition, no restriction over here, and all these 6 people, they have to stand in a line. Then how, in how many ways this could be done? That we could make
6 factorial.
very good, mashallah. That could be 6 factorial. But now it says the 2 women must be at the front. The 2 women must be at the front. So that means if the 2 women are at the front, the 4 men would be at the back. So how have you answered this A part?
2 factorial into 4 factorial.
Exactly. This is 2
Yes.
factorial into 4 factorial. Now, if the question was that the 2 women can either be at the front or they have to be at the back, then
So
we'll
it's
add
1 times 4p 1 times 4 factorial.
So we'll add a 2 factorial to this.
or you can multiply it with 2 factorial. If it says okay, the 2 women can either be at the front or at the back, okay? So that is going to be
So
2.
isn't this an OR case? Wouldn't
Yeah,
we
that
use
is,
a plus?
that is an OR case, na? So that is why, like, this is going to be all women here and then all men. Or it can be all men and then all women. So these are 2 different arrangements. That is why I'm writing this 2 factorial. Or you can simply write times 2
So
factorial.
that doesn't
So
give the
don't we
right
use an
answer.
addition sign when you use an
Why?
OR?
Or sir, why aren't we doing 4p1 times 2p1 times 4 factorial?
4p1. 4p1 means you're picking one out of these 4. We are keeping them together. All the 4 men are together. All these 2 women are together. So that is why you either write it as 2p.
But sir, they're not specifying that. They're only saying there must be a woman at the front and a man at the back. We don't have to keep all of the men together.
Exactly. But that is for the case when you have to have 1 man and 1 woman. Now we are keeping both the two women and all the 4 men together.
No, sir. अगर हम लोग front पे 2 women है हमारे पास, ठीक है, और front पे we need to keep a woman. So that means कि हम 2p1 करेंगे because we can only choose one of them, ठीक है. And then at the last position we have 4 men जिसमें से हमें एक पीछे खड़ा करना ही करना है. So we'll use 4p1. और बीच में we have
women are fixed at the first
for that
position.
we'll do 4 factorial.
Beta, listen, beta, I really appreciate you people are so openly discussing these things. The thing is, beta, it says the 2 women must be at the front. It doesn't say that one of the 2 women must be at the front. It says the 2
And I
women.
thought you were talking about the second part.
Oh, sir, are you talking about the A part? I thought you were talking.
I'm still at the A part. I'm still at the A part.
Oh, sorry, sir. मुझे लगा B की बात कर रहे हैं. So sorry.
Okay. I'm still at the A part. I just added something into it that if the question was that the 2 women can either be at the front or they can be at the back, so then this could be the answer to that. Okay. So now can I move to this B part now? It says there must be a woman at the front and a man at the back. Yeah, for this you are absolutely right, because 2p1 at the front and 4p1 at the back, okay? And in between we have 3 men and 1 woman standing in any order. So that is going to be 4 factorial. So this is 2p1 times 4 factorial times 4p1. Okay, so that was absolutely right. Okay.
Sir,
Yeah.
I just want to clarify something. In the first part where you gave the alternate case, it's basically 2 factorial into 4 factorial plus 2 factorial into 4 factorial,
No.
right? Because it's
Yeah.
OR case.
Absolutely. This is 2 factorial into 4 factorial plus 4 factorial into 2 factorial, Or you can simply say 2 factorial into 4 factorial times 2, or you can also say 2 factorial into 4 factorial times 2 factorial, because you know these two sets, if you have two sets and you want to arrange them, one box for the women, the second for the men, in how many ways you can arrange this, so that is going to be this 2 factorial. Okay, so any one of these three is going to be the correct answer. Yes.
Thank you, sir.
Okay, beta. Now it says the two women must be separated. The two women must be separated. Now there are many ways of doing it. There are many ways of doing it, but I will give you the smartest way of doing that. See, there are four men, so split them like this. Okay, now these arrows are the spaces. If you put the women in any of these two spaces, they will never be able to be together. We have already discussed this in one of our classes as well. So this would be, how many spaces are available for these two women?
And 5.
5. So this would be 5p2. Okay, times 4 factorial. Okay,
Yes, sir.
okay. Then it says, I can wait if any one of you still thinking on it and she wants to confirm it. Okay, you can let me finish this question. You can ask me if the problem in any of these 5 parts. Okay, then it says the four men must not be separated. Before this, let me ask you a question. That, you know, we're making all these 6 people stand in a line, and the condition is that the two women must be together. The two women must be together. So how would you do that?
So 2 factorial into 4 factorial into 5 factorial.
No, no. You were very close. The two
So
women
2
at the 2 factorial times.
times 4 factorial times 2 factorial.
Nahin. Again, look at this.
There are
If
2 factorial to 5 factorial?
yeah, that is the answer. When you're saying 2 factorial into 4 factorial, that means you're keeping the two women together. You're keeping the 4 men together as well. Okay, now let's keep these two women together. We tie them with a rope. Okay, you are going to be together wherever you go. Okay, now then there are 4 men. This can be like, you know, these 4 men can be anywhere. So now we have how many objects to permute? We have 1, 2, 3, 4, 5. So this is going to be 5 factorial times 2 factorial for these two women to be in different order. Okay, so this is 5 factorial times 2 factorial, or you can also say 2 factorial times 5 factorial. Is that clear?
Yes, sir.
Okay, now let's suppose the condition is, that is the D part, that the 4 men must be together. 4 men must be together. So we'll put all these 4 men in a dabba like this. Okay, khabardar, you will stay together. And women can both be towards the right, they can both be towards the left, or it can be like this. So now, how many things have to be permuted now?
3.
3. So this is going to be 3 factorial times 4 factorial, because these men can be in any order over here. So this is going to be 3
Times 2
factorial
factorial.
times 4 factorial. Okay?
Shouldn't it also be times 2 factorial?
What
Because हम
would,
women change कर सकते हैं.
so that is included in this 3 factorial. Now, this is one dabba for the men, and then these are 2 women. They can be anywhere. Okay? So that is why
Okay, yes.
we have this 3
Okay, thank
factorial. Okay, the last part is really very tricky. It says no two men may stand next to each other.
Sir, वो तो 0 नहीं होगी possibility.
Yeah, you must be,
Yes, 0.
yeah, you must have courage to say 0, because two men, this is not possible that all men are separated from each other. Okay, then there should be at least 3 women if you want to do that. Okay, So this was it. And uh, if there is no question, then I can clear all these drawings here. Hmm? Is there any student who needs to ask anything? Hmm? Okay, then I can clear this. This way you can try this question number 4, you can try question number 5, but I want you people to try this 6th question. That will be the last question for our today's class. Please try question number 6. You must have at least read this 6th question. Now it says find how many of the 6-digit numbers that can be made from these 6 digits where there's 1 1 2 twos and there are 3 threes. Now let me ask you first of all, before we go into the A and the B part, how many 6 digits number we can make from all these 6 digits? Yes, there's no condition. Hmm?
Sir, 6 factorial over 2 factorial times 3 factorial.
Geo, very good, mashallah, great. That is 6 factorial over 2 factorial into 3 factorial. That is the total number of 6-digit numbers. Now it says begin with 2. Now there is a condition that you must have a 2 at the beginning, okay? Now this 2 is fixed, okay? Don't say 2p1 because you're going to pick, no, these are just 2 twos. I have picked 1 2 over here and I fixed it here. Now, what about these remaining 5 slots here?
Sir,
5
5
factorial over 3 factorial.
Very
Sir,
good. 5 factorial over 3 factorial, because when you're fixed 2 over here, that would mean that this is a situation like this. Out of these 5, we have these 3's getting repeated 3 times. So that is why you have 3 factorial here. Then it says are not divisible by 2. They are not divisible by 2. So that would mean, let's split this. First of all, you keep a 1 here, okay? If you have kept a 1 here, then this would be for these 5 slots, 5 factorial over 2
3
factorial
factorial.
into 3 factorial. Yes or no?
Yes,
Yes.
sir.
And if you fix a 3 over here, you fix a 3 over here.
5
So,
factorial over 2 factorial into 2 factorial.
yeah, mashallah, mashallah. So this is going to be 5 factorial over 2 factorial into 2 factorial. So guys, that is it from the day. And inshallah, we'll continue with this. And you should try all these questions from this exercise. Let me minimize this a bit so that you can see all these questions. You try these questions from this exercise 5D like this, okay? And then you can go on to this is the last question over here, okay? Tomorrow is our last day for practicing the textbook questions, and after that, we shall be trying the questions from past papers, okay? Thank you very much.